Okay, so here one thing is shown that T on and T off, these two are together. Total time is the total time period T, and this T is the inverse of frequency. So what is the switching frequency? You can set by setting the time period. But for practical case, when you see this one A and B, we can say there is a voltage drop. So during the on state, we can say three conditions or three cases. Case 1, when between A and B there is a voltage drop, that we can say it is a B switching. So for the first case, we can consider there is a voltage drop across the line during the on state. Okay, a small voltage drop for the case 1. Case 2, there is a on state resistance. This R1 value is very less, very less, 0.001 ohm, like that. It is, but it is still there is a on state resistance. So this on state resistance, due to this on state resistance, there is a small voltage drop across this line. And case 3, when both a small voltage drop and R on state resistance both are present. Okay, so there is a voltage drop across this R1, and as well as a small voltage also be present in this case. R1 is a small finite value, and here the V switch is not equal to 0. That means a voltage drop across switch which will be there. So we can see that during the on state there is a voltage drop we have, and during the on state, in the during the ideal case, we have considered that there should not be any leakage current, but for practically there is a leakage current. Though the leakage current is very less, but still there is a small current flow through this path. So during this A and B, and during the off state where current cannot be flow through it, but still in the practical switches there is a leakage current flow from A to B, and we can consider there is a off-state voltage. So off-state resistance is very high. We can consider that off-state voltage is very high. So when current is flowing through it, the I switch will be V switch. That means the voltage supply across the switch divided by this off-state resistance. As the off-state resistance is very high, so it is I switch will be very less. So delay during this is the for conduction blocking loss. Okay, so first one on state, it is a on state conduction loss. During the off state, it is called the off state blocking loss. And another loss is there which is occurred during the change of the state. That means from on state to off state or off state to on state. These are called the switching loss. So losses in the practical switch, we can say this is switching loss during state transition, conduction loss during on state, and blocking loss during off state.